Hey everyone, and welcome to today's explainer. If you've ever found yourself totally scratching your head over the difference between speed and velocity, honestly, you are in the exact right place. Today, we're going to clear up all your concepts about motion using a really simple step-by-step approach. We are ditching the heavy textbook jargon entirely and focusing on real, true conceptual understanding.
So, here's our quick roadmap for today. We'll start with the basics of distance and speed, introduce the crucial concept of direction, properly define velocity, tackle some super common exam traps, look at a really fascinating circular path paradox, and then wrap up with a quick revision. Okay, let's dive right in.
All right, part 1, basics, distance, and speed. Let's start with a very basic, grounded example, just to anchor our understanding before we add any complexities. I want you to picture this. Imagine something. Maybe it's you walking across a room, or maybe a toy car rolling across the floor, moving from point A to point B. First, it covers a total distance of 10 meters. Second, let's say this entire movement takes exactly 5 seconds.
Now, to figure out the speed of this object, we just do a little quick math. We divide that 10-meter distance by the 5 seconds of time. 10 divided by 5 gives us 2 meters per second. Boom! That 2 meters per second is our speed between those 2 points.
But hold on a second. Instead of just memorizing the math formula and moving on, I really want you to ask yourself, what does 2 meters per second actually mean in the real world? Let's not just treat it as some abstract number on a page.
The answer is actually beautifully simple. It literally tells us that this object covers exactly 2 meters of distance during every single second that passes. Tick, second 1, 2 meters. Tick, second 2, another 2 meters. And you know, that is the true concept of speed. It's simply your rate of covering distance.
Okay, moving to part 2, adding direction and introducing displacement. You've got the basics down perfectly, so let's pivot and level up. We are going to introduce direction.
Think about it like this. If I just casually say, hey, I moved 5 meters, well, that's just a distance. We know the size of the space between 2 points, sure, but we have absolutely no idea which way I went. Up, down, left, right, who knows? But if I change that and say, I moved 5 meters towards the right, we now have a distance in a very specific direction. In physics, this modified direction-specific form of distance is known as displacement.
Let's throw some official exam vocabulary at this, just so we're covered. In simple English, distance is a scalar quantity, meaning it only gives us the size, or the magnitude. Displacement, however, is a vector quantity, because it includes both that magnitude and a specific direction. Definitely remember this distinction. It's going to be absolute gold for your exams.
Part 3, understanding velocity. So, how does this whole scalar vector scaffolding apply when we start talking about how fast something is moving?
Well, it's the exact same relationship we just saw. Saying 30 meters per second is just your speed. It tells us how fast you're going, but not where to. Therefore, speed is a scalar quantity. But if we say 30 meters per second towards north, suddenly that speed in a specific direction becomes a brand new quantity. Scientists call this velocity. So velocity is a vector quantity. It's got speed and it's got direction.
Now, here is a super quick exam tip for you. Despite being completely different quantities, one scalar, one vector, they actually both share the exact same SI unit, which is meters per second. Keep that little fact tucked away in your notes. Section 4, Formulas and Exam Traps. Now that we have our definitions totally straight, let's look at how we calculate these. And more importantly, let's spot a massive trap you absolutely need to avoid. These are the correct formulas you want to use. Notice how like pairs with like. Speed, which is a scalar, equals distance, another scalar, divided by time. Meanwhile, velocity, which is a vector, equals displacement, a vector, divided by time. It's perfectly balanced.
So, the crucial takeaway here is this. If you ever catch yourself writing speed equals displacement divided by time, stop right there. It is completely mathematically wrong. Why? Because the left side of your equation is a scalar quantity, but the right side is using a vector quantity. A scalar can literally never equal a vector. Always make sure your concepts match up.
Okay, part 5, the circular path paradox. Let's take all of these rules we've just learned and apply them to the real world to see how they behave in the wild.
Picture 2 cars taking a road trip from city A to city B. Car 1 takes a long, winding 30-kilometer road that takes 5 hours. That's pure distance, giving us an average speed of 6 kilometers per hour. But Car 2, it takes a direct, straight-line path of 18 kilometers exactly south, taking 2 hours. Because we have a straight line with a specific direction, this is displacement, giving us a velocity of 9 kilometers per hour south. Makes sense, right?
But here is where it gets super weird, and frankly, kind of fascinating. Imagine something moving in a giant, perfect circle. It travels all the way around the track and returns perfectly to its exact starting point after, let's say, 2 hours. This is the ultimate test of our terms. The distance covered by this object is the entire outer edge of that circle, the full circumference. So we definitely have a distance and therefore an average speed. However, let's calculate displacement. Because the initial starting point and the final ending point are the exact same place, the object hasn't actually been displaced from its origin at all, meaning the displacement is a big fat zero. And since our formula for velocity dictates that it equals displacement divided by time, well, if displacement is 0, then 0 divided by 2 hours is just 0. So your average velocity for that entire, exhausting circular trip is exactly 0 meters per second, even though you are moving the whole time and have an average speed. That right there is the pure power of understanding vectors.
Finally, Section 6, Quick Exam Revision. Let's do a fast recap to lock this all in before we wrap up today's explainer.
Keep these core building blocks in your back pocket. Distance and speed give us size only, making them scalar quantities. Displacement and velocity include specific directions, making them vector quantities. Always match your variables correctly in your formulas. Speed pairs with distance, velocity pairs with displacement. And never forget that awesome circle paradox. If you return to your exact starting point, your overall displacement and therefore your average velocity is absolutely 0.
So I'm going to leave you with a quick question to chew on. Think about this the next time you are sitting in a moving car looking at the dashboard. Is that dial telling you your speed or is it telling you your velocity? Think about what's missing from that dial. Keep questioning the physics of the world around you, keep learning, and I will see you in the next explainer.